This time, I'm gonna talk to you. I'm gonna share a few stories about monitoring containers with a little bit of a tilt towards Kubernetes. So my name is Gianluca. I work at Sysdig, and the problem that we have been observing for a long time now is this: is that for the vast majority of small, medium companies, monitoring should be something like this. You extract a bunch of data that enables you visibility into different layers of your infrastructure and architecture. So you move from the lower level provisioning layer towards language runtime, towards custom application instrumentation with StatsD or things like that. Then you pipe all these into essentially some sort of data engine that does all sort of, noise removal, aggregations, alerting and things like that. And then you, as a user, you should just have some sort of very nicely formatted dashboards that are really straight to the point and point you in a very easy to consume way if everything is all right. And many times you don't even want to see a dashboard, you just care about having just unicorn and rainbow alerts, let's call it like that. But what happens really is that we have observed that when you go with containers, the unicorn dashboards don't come out that much. And so I want to spend a few minutes telling you why we think is that. So pretty much I'm going to share a few best practices that we learned by working at this point with hundreds of small, medium businesses who are interested in doing monitoring in an easy way, but at the same time we're interested into essentially developing their workloads on containerized environment for all the benefits that they provide. And so for this talk, I'm going to use occasionally some of the Sysdig tools, but this has to be taken in a completely vendor-neutral way, as long as as long as a particular monitoring or troubleshooting tools respects the best practices that I'm going to share with you is totally fine. I'm just using those because that's what I'm most familiar with. So again, this is a standard that shows my very poor drawing skills. Just a standard infrastructure. We could call it a monolithic application or something like that. And we can see how the topology is pretty simple. And what happens with containers is that this workload is going to be scheduled in multiple copies among multiple nodes by whatever cluster orchestrator of the day you are going to be using. And all these workloads are going to be communicating with each other using all sorts of layers of virtual networking. If you've used containers, you know perfectly what I mean. So this clearly causes a big problem when it comes to monitoring and visibility. So you have to be extremely dynamic, and you have to adopt new best practices in order to get the most value out of for the visibility of the environment. So how does all this impact monitoring? Again, by working with a lot of customers, we have identified that when you move into containers, when it comes to monitoring, there are 4 things that are harder to do now. The first one is, of course, getting the data, as we'll see in a second, because containers are isolated. So also the data in there is a little bit more isolated. The second one is because since all these workloads are highly dynamic and they move around, you need to make sense of the data, and making sense of the data comes with a few best practices in itself. Then the other element, which I already covered a little bit in my previous short talk, is essentially the troubleshooting part. So I have this idea essentially that as long as you have visibility enables you to do proper monitoring and proper troubleshooting. So monitoring and troubleshooting really go together, because monitoring, it's what ideally prevent issues from happening again, but troubleshooting is what enables you to find the root causes of the issues in the first place, right? And then the third one is the people. So we have observed that by moving to containerized environments and by moving to user-friendly cluster orchestrators such as Kubernetes, the developers who write the applications are much more prone to get involved with all the life cycles of the application. So we have really seen, traditional developers writing their own Kubernetes manifest to orchestrate the application in production, and then wanting to monitoring them. So the move to microservices and to containerized environments somehow has also an effect on the semantics of the team relationship from what we have observed. So getting the data, again, seeing inside containers is essentially a big pain in the ass. I'm sure if you've used containers, you know what I mean, from all points of view, from the troubleshooting point of view, from the monitoring point of view, because containers are isolated because of namespaces, and they run a very minimal runtime where you don't have all the tool belt of things that you might want to have when you have essentially a visibility issues. So, but at the same time, these are the exact same reasons why people are using containers, right? Because they allow us a much more dynamic workflow. So to extract metrics and essentially get the best visibility out of your containers, we have observed two strategies in the field. Again, we have these statistics of several hundred customers, so that's pretty significant. And we have observed that the first strategy is the one of leveraging the cluster orchestrator to somehow give you a hand when it comes to extracting metrics. So in the case of Kubernetes explored this concept of pods. So pods are groups of containers that the cluster orchestrators guarantees that they will always be scheduled on the same host. And not only that, but these containers, they will share some resources. In particular, they will share, in the case of Kubernetes, the network namespace. So localhost for container 1 is the same as localhost for the monitoring container. And they will also be able to share volumes. So something that you can do is you can deploy essentially a sidekick container along with the containers containing your application, and the monitoring container will be essentially, will contain all the logic to poll, for example, extracting the metric from your MySQL database or things like that, and making them available either with a push or with a pull model through your monitoring framework and to your big data engine that we saw in the first slide. This is a model that works perfectly well. It's widely adopted, for example, in Prometheus, which is a very popular monitoring tool for containers. And the only disadvantage is that, of course, you have to do a little bit of work every time you ship a new application or something like that. The other approach that we experimented at SysDig is, as I talked before, is to taking a look at a different angle. So the nice thing about running application on a modern operating system is that regardless where your applications are scheduled, whether if they are outside a container or inside a container, they will, at some point, every time they have to do meaningful work, they will have to talk to the kernel, right, via the system call API. So what happens if instead of going and poking inside each container, you just instrument the system call layer and you capture then everything that's going on in all container, and then you essentially direct this flow towards your monitoring agent that lives on the system. So by doing this, you are able to see inside the containers from outside the containers. And actually it's pretty easy. So say that in container 2, you see that a new network connection has been accepted by Apache. And then from the cluster orchestrator, you get the metadata that this Apache was living in this specific context, in this specific container. You correlate the two things and you have a container-aware monitoring tool without having to do anything inside your container. And again, we use a custom kernel module, but there are many approaches. So for example, we have seen a lot of activity lately using the eBPF framework in the Linux kernel that allows you to get very deep information from within the kernel in a completely safe way without having to, manipulate any potentially unsafe thing. And so this is how you get the data. Once you've gotten the data, you need to make sense out of this data. And as I was saying, this is something very important. And we have worked with a lot of customers and we have observed these 4 bullet items to be very important. The first one is that especially if you are, well, if you're a big company, yes, you can afford it. But if you're a small company, you should really not be involved in the craft of instrumenting your code, and you should let your monitoring system do as much as it can for you. We had, for example, this customer who was saying, oh, I I came up with this very cool idea. I have a big Kubernetes workload, and I have a lot of Java applications running inside containers. So I have this little script that runs inside my containers that fetches through a JMX proxy, fetches all the JVM statistics such as garbage collection and heap. Okay, that is horrible. If you're spending your time extracting such basic system metrics, I understand that it's inside a container, and so it's not as easy as it would be from if this application was being just in the host. But your monitoring tool should provide you the primitives to clearly cross the container boundaries and extract anything you need in that case. So everything that's related to namespace crossing or things like that should be provided by your monitoring tool. So that gets to the second point. The only thing that you should really care about are essentially your stats metric, right? That's about it. So should be the number of cookies that have been ordered through your online shopping website, things like that. So things that your monitoring tool cannot know by itself. The other item, which is it's really the core, and a lot of talks I've already touched on this in these past couple of days, is that tagging is really important. Every metric should be absolutely tagged. So let me show you what I mean. This is Sysdig Monitor. So this is just an infrastructure monitoring tool where I have a workload with several containers over here. And you can see that I have here basic system statistics on them, which again is cool. But you can see how there is some affinity between these containers, right? For example, this WordPress container, there's another one, and then there's another one. So just looking at those metrics, at those individual metrics, doesn't make sense, right? So you need to make sure that each of these metrics is tagged in the right context, which in the case of Kubernetes is, for example, grouping them by the concept of namespace. So now you can see that inside my two namespaces, dev and production, I have two copies of the WordPress microservice, each one with a replication factor of 3, so I have 3 containers. And my monitoring tool needs to be able to automatically provide me this row, right? So in this case, this is the average. We said that average is bad, so here you can substitute a max, a percentile, anything you want. And this row is what is really important, right? This is really the performance of the microservice as a whole, and your monitoring tool should provide you with enough context so that you can tag things. And if things move around, so if this WordPress container dies and gets rescheduled in another host, the monitoring tool should automatically pick it up and put it back in the right context. And then it's a plus if you look at things even from a lower level, such as the one from the system call. So for example, then by clicking on my entire service, I can take a look at pretty granular things, such as the individual HTTP requests that my containers are doing with the response time and things like that. And this happens all because we looked at the actual payload that is going on the I/O system calls. So tagging is really the most important things when you are doing monitoring for containers. And so you should be making sure that tagging is heavily integrated with Kubernetes. So Kubernetes exports for each of your containers, there is a very significant and large context around it. So you should make sure, and each of these things, for example, you have a pod, you have the deployment, you have the namespace. Each of those things have several labels that the operator or the developer can choose, and you should make sure that your monitoring tool correctly correlates those metrics with the proper tags. Because then the other point is, you should absolutely not be involved in tagging metrics manually. We have seen, I'm saying this might seem a little bit trivial, but we have seen a lot of customers who actually were in the code where they were pushing their stats metric, and they were like, okay, I'm pushing this number of requests in my REST controller, and then I'm gonna append at least this big of tags, which come from Kubernetes. You know how stressful it is to get at the point in the code where you're pushing the metric, get the whole chain of tags that apply to that specific metrics? It's absolutely awful. Like actually in Kubernetes, it's pretty difficult. You would have to use some sort of downwards API or manually propagate things to through environment variables. So your monitoring tool should be able to pick the metadata from one side, pick the stats metric from one side, and automatically correlate them, so that then the only thing that you need to do is push your single stats metric without any context. And the other one, also obvious from the other talks that we have seen, is that you should collect everything, exactly like you do with logs, that you collect gigabyte of logs per hour, and then you just use grep of Elasticsearch or anything even fancier to just get the information that you wanted to do for your specific context. Same thing is for metrics. You should collect millions and millions of metrics because you never know when they are going to become useful. So we have actually seen tons of troubleshooting use cases where just after an outage, metrics that no one would have thought about in the first place helped solve the mystery. So, okay, and this is enough for making sense of the data. The other item is clearly the troubleshooting one. As I said, I really like doing troubleshooting, and there is a real need in the community for more container-aware troubleshooting, which is partly a state of mind and partly like an implementation problems, because many of the tools that we have around are not yet container-aware. For example, this is a screenshot that I got from an issue on Kubernetes where there was an issue that they were trying to troubleshoot, but they were like, oh, I'm running the BusyBox container image, so I'm not gonna have all the tools that I need to do my job. So you need to make sure that your troubleshooting tools take care of the container identity. So this is what I mean. You've probably seen this demo already at some point, but it's always fun to show. So this is just a Curses UI for sysdig, which is a system call-based troubleshooting tool. And this is showing me a bunch of processes that are running in my system, and all these are containerized. So what happens if I switch to a view that is based on containers? This is now showing me all the containers in my system, as you can see here in the right side of the screen, along with their images and the resources that they are consuming. So, okay, this is already a little bit better, you know, container-based troubleshooting. But something that I can do, for example, let's say that I'm trying to troubleshoot a Redis issue. So I'm filtering for Redis, and I can see that I have exactly 2 containers with Redis. The other 2 ones are just the placeholder that Kubernetes puts to keep a hold on the network namespace. So I have Redis, and if I press enter, I like to drill down and start the troubleshooting inside this specific container. So now it's showing me just the processes running in these containers. And while I'm inside this container, I'm going to switch view, and I'm going to switch to the network connections. And this is showing me in real time a netstat-like view of all the connections that are going on in this container. This is really not trivial. If you try to do this with netstat, you'll have to recognize that you have to manually change namespace. And same thing if you try to capture things with TCP dump, you have to guess the network interface that matches to this network namespace. And since this is a system call-based troubleshooting tool, once I am here inside this connection, I can press F5 and I go into echo mode, where this is actually showing me the payload of that is going on this Redis connection, which is, if you've ever done Redis programming, these are just GET requests for the simple Redis protocol where my application is requesting a counter. So notice how easy it is, and I really think that troubleshooting for containers should be this easy, whatever, you know, best practice or troubleshooting tool you have. There is still one thing that I don't like that much, which is here, when I started my troubleshooting, I started from the containers view, but notice how these names are quite messy, right? These names were not chosen by me, these container names were not chosen by me, were not chosen by my application developers, because these were automatically picked by Kubernetes. So when I have to troubleshooting something quickly, I don't even know which container I should look at. So why we don't bring the concept of tagging also for our system level troubleshooting tool? So instead of starting the exploration from the container name, let's start it from the Kubernetes namespace. So here I can see that on this machine, I have containers running in both the dev and in the production namespace. And then I can select this, and this will show me the pods, which again, the pods are the containers wrapper in Kubernetes. And notice how the names are much nicer, and most importantly, notice the labels here. Now we are talking. This is the set of metadata that as an application developer or infrastructure operator, I explicitly chose. So I can do a troubleshooting, even if it's advanced, I can do a troubleshooting driven by those things. So let's explore, for example, one. I have over here this Java app pod. If I select it, this will show me the container that is running in this pod. And if I select it, it will show me the commands. In this case, I have a Tomcat application, and then I have an Nginx reverse proxy in front of this Java application, which probably just does some SSL offloading. But let's see. So let's select the Nginx worker process, and while I'm selecting it, let me look at the activity I/O that is doing, and you can see how I can trace each individual HTTP request that this container is doing from outside the container without touching the container itself, which is extremely important for, especially when you're doing live production troubleshooting. And don't let yourself be fooled by the fact that a troubleshooting tool should just work with network data, because you should be able, while you're selecting, for example, this Nginx process, to switch to the files in real time. Notice the files that the Nginx process is opening, reading, or writing. So these are the files. It's very difficult in Linux to get a metric broken down by individual file. And so you can see that Nginx is writing to the access.log, and since we are seeing things that the system calls, I can press F5, and I can look at the individual log entries that Nginx is writing as we speak inside the log, all outside. So this helps essentially crossing the container boundaries and making things a bit more user-friendly. So this is what I meant with troubleshooting. The last item I had is about people. So what we have observed is that people are taking the concept of container scheduling and application deploying in containerized environment to create some sort of multi-tenant clusters where several applications and several teams can coexist in a single cluster. So monitoring should also be focused and tailored around those individual teams, even if you're collecting metrics from a single pipe, which could be, the single host. And so what we found out is this. What we try to do is a monitoring tool that from the left ingests all the metrics. Could be statistic, could be system calls, everything you want. From the right, it extracts the service metadata, so labels for containers, labels for Kubernetes entities, and then it routes these single specific metrics to each individual team depending on their needs. So if team 1 just needs to operate on one specific Kubernetes deployment, even if the cluster contains 100 different other applications that are owned by other teams, team 1 should just see the metrics for that specific application and should just get the custom set of alerts and dashboards. So we have been experimenting with this, and our customers were happy, but then they said, but still our users screw up a lot because they end up doing a lot of copy and pasting on things for different teams. And this also is linked to a talk that we have seen before where the presenter was saying, let's also make dashboarding and alerting as a code. And so we started saying, can we move this concept of per team monitoring inside the code? And so we did an experiment. So this is the manifest that I used for deploying that Kubernetes service that you were seeing there. So you can see it's a simple Kubernetes deployment where I'm running 3 replicas of a WordPress container over here. This is the template. You can see I'm even putting a password in clear text as an environment variable. Very bad. And then you can see that in the annotations, which is essentially a free section that Kubernetes lets for third-party consumption, I am specifying annotations that are supposed to be parsed by my monitoring tool. So I'm saying, hey, whenever you deploy this application, also create me a team for my monitoring tool where these members will have access to. I want these dashboards pre-made, and I also want my alerts as part of this application deployment. So I want an alert on the response time. I want an alert whenever the response time goes above 500 milliseconds over a 1-minute window. And I also want an alert when every single container has a CPU that goes above 80% over the span of 1 minute. So this concept of monitoring as a code, we think is very cool, because then when you deploy this service, your monitoring tool can automatically create the entities that then become immutable. And so you keep the monitoring, dashboarding, and alerting right exactly as you will deploy your application as a code. And so let's see, for example, over here. Here I am in my root team, and this is the team that can see everything. But when I deployed my WordPress, which again, I deployed 2 copies of this, one in the dev and one in the prod, my monitoring tool automatically creates me 2 teams, and in one team, for example, if I switch to the dev, I am just being able to see internet connection. I'm just being able to see the individual 3 WordPress containers that match the context that I specified in my manifest. And we have seen that small and medium companies, which usually don't have the resources, to create these sort of things by themselves, can gain a lot of benefits by having a monitoring tool and a monitoring framework that provides this primitive, that provides not only infrastructure as a code, but also monitoring, dashboarding, and alerting as a code. Because then you can see over here that then you go to dashboard, and yeah, you see all the SQL queries that just that specific application is doing, and also the alerts. You can see the 2 alerts that I configured that are automatically set up, and they are immutable. So if you want to change them, you change them in the code, you commit them in Git, and the dashboard will be automatically updated exactly the same as the alerts. And we think that this concept is quite interesting. It's gained a lot of popularity. And again, the use cases are several. The use cases are around everything that revolves multiple teams deploying their application on a single cluster, which again, the majority of our customers who have containerized workload do. They really like to pack things really like crazy, having hosts with dozens, if not even more, hundreds of containers. And yeah, this is essentially all I had. If you want to check more pointers around this concept, we have a few blog posts where we described a little bit more in details how this concept of monitoring as a code works. And that being said, thank you very much.